Hello General Math students. In this video we're going to do some critical path analysis. So finding the critical path through a network allows us to find the shortest way to get from one end of the network, say the start of the network, in this case which is over here, to the end of the network or the finish of the network. Now this involves an algorithm or a process where we start with a forward scan. Okay, which will be from left to right through the network, from the start to the finish, where we want to find the longest way to get from one vertex to the next. And then this is followed by the backward scan, where we come back from the finish to the start, and we're trying to, that case, to find the shortest way from each vertex to back to the next one. Okay, so my little analogy for remembering this is on the forward scan we play football, and in football you want to find the biggest score. You want to get the biggest score possible, and on the way back, on the backward scan, we play golf, and in golf we want the lowest score possible. So we play football on the way forward and golf on the way back. F for football, G for golf, FG in the alphabet. It's just a way that helps me to remember which one comes first. So I'm going to complete the forward scan here, and to do that we start at the start, and we put a 0 in the top of this little house. These little house shapes are at each vertex, and they're just there, provided for you in order to keep a track of the forward scan and the backward scan. So we're going to find the longest way to get to each vertex from here, and there's only one way to get to the next three vertexes, or vertices, I should say. And going along A, that's going to take 8. Along C to this vertex is 12. And in fact, there's actually two ways to get there. We could go via C, which would be 12. G'day General Math students. In this video, we're going to be doing some critical path analysis. So critical path analysis allows us to find the shortest way through a network from the start to the finish. So in this case, this would be the start, and this is the finish. So there's lots of different ways you could travel through this network. We're going to find the shortest way from the start to the finish. Now, this involves a process where we complete what we call a forward scan. And on the forward scan, we're looking for I suppose what we'd say the longest way to get from each vertex to the next one. Then, once we've done that, we complete the backward scan. Coming back that way. So the forward scan is from left to right, from start to finish. The backward scan is in the opposite direction. And we're trying to find the shortest way when we do that. So I have a bit of a way to remember which one's which. I say that on the forward scan, we're playing football. So first we play football. And in football, of course, you want to get the maximum score possible. And then on the backward scan, we play golf. And in golf, you want to get the lowest score possible. So I always say football, then golf. Footy, then golf. And F comes before G in the alphabet as well, so that's another way to remember which one we're doing first. So let's do the forward scan and see what this is all about. So we start here at the beginning, and we have these houses at each vertex, this house shape, which is going to allow us to keep track of the forward scan, then the backward scan. And we use the top of the house for the forward scan, and we're going to start at the beginning, and it's 0 goes in here, because we haven't travelled any distance yet. Now, we want to find the longest way to get to each vertex. Alright, so we'll start from this one, and there's only one way to go along here to this activity A, and that will take 8. Pardon me. Now, to get to this house here, or this vertex, we could go 8 and 13, or we could go along here for 12, or we could come this way and go 9 and 15 for 24. So the biggest one is 24, that way. The longest way is to go from here to here to get to that vertex. That's longer than going along here, which is only 12, or along here, which is only 21. So we'll put 24 in there. Of course, we need to show this one here as well. That's 9 to get to there. Righto, so now to get to this vertex, there's only one way, so that involves 8 and 12. We add up as we go, so that's 20 to get to there. So next, down here, I mean, you can just sort of do any real, there's no real way of doing the ordering, but I'll do this one next, where we go from along G. 9 and 10 makes 19, that's the only option to get to there. So now to get to this vertex, we could do 24 and 9, which makes 33, or we could go along here. 19 and 0 is 19, so of course we're going to go with the biggest one because we're doing the forward scan, so 33 in here. So now we'll do this one here. Okay, so we could go 19 and 5 to make 24, 33 and 8 makes 41, so that is the longest one, so we'd come via that one and put a 41 in there. Alright, so now to get to the last vertex, we can come via this one. 20 and 12 makes 32, 33 and 11 makes 44, or 41 and 6 makes 47, so we're going to go with that last one. So we end up with a 47 in there. So that is the forward scan. Now let's complete the backward scan. So we're going to switch to the bottom of the house, and we just take this number 47 and write it down again here. Now remember, we're looking for the shortest way back to each vertex. So coming back along this one, there's only one way to go, and that's from 47, and we take 6 off, and that gives us 41 down there. So we're taking off the amount each time this way. Okay, to get back to this vertex, there's only one way to do it. 47 take 12 gives us 35. Now, to get to this vertex, we could take 11 off 47, which gives us 36. Or we could come back via this one, which is 41 take 8, and that gives us 33. So now we're looking for the shortest way to get back. So that's going to mean instead of 46, from here, we're going to go that way, and it's going to be 33 in there. So we're looking for the shortest way to get back to each vertex now. Okay, this one down here, we could do 41 take 5 to give 36 down in there. Or we could do 33 take 0, which gives 33. That 33 is lower, so we'll go with that. Okay, to get back to this vertex, there's only one option from there. 33 take 9, which will give 24. Okay, to get back to this vertex up here, 35 take 12 would be 23, or 24 take 13 gives 11. So 11 is the shortest way back. This vertex here, 2 to go. 33 take 10 would give 23 down there. 24 take 15 would give 9 down there. So that's the lowest of those two. So now we're just finding the shortest way back to this one. 11 take 8 would give 3. 24 take 12 would give 12. Or 9 take 9 gives 0. And that's what we want to see at the end, is that we have 0, 0. You should always end up with a 0, 0 at the end. If you don't get that, something's gone wrong with either the forwards or the backwards scan. Okay, so we're just about there. What we do to finish off is we identify any of the vertices, the houses on the vertices that have the same number in the top and the bottom from the forwards and backwards scan. And that tells us our critical path. So we have this one, then here we've got a 9, 9, so we've come back along here. And then we have 24s that match there, so we're back along that. And then back to this one, which has our 33s. Down here, which are 41s. And back to the end, which with our 47s. They all have matching numbers top and bottom. So that is the critical path, which we would detail thusly. We go activity B, and then we do activity F, H, K, and finally M. That is our critical path. Yeah, and the length of that critical path, of course, is 47. I'll just say 47 units here. We don't have any real context to this problem, but if it was a road network, it would be 47 kilometers, say, or it could be based on times to do activities, so 47 minutes, who knows. Okay guys, so go ahead and access the questions in the description for the video, and let's try some critical path analysis.